Hello everyone, I'm Michelangelo Alicando, and in this video, we are going to learn about accelerometer and how it works. So first, let us define what accelerometer is. Accelerometer is an electromechanical device that measures the vibration or acceleration of motion of a structure, where acceleration is the rate of change of an object in velocity per unit of time that is measured in meters per second squared. Like the continuous force of gravity, or, as is the case with many mobile devices, dynamic to sense movement or vibrations. So for example, when a ball is falling and travels with gravity, the acceleration will be 9.8 meters per second squared. The force caused by vibration, or a change in motion, causes the mass to squeeze the piezoelectrical material, which produces an electrical charge that is proportional to the force exerted upon it. Since the charge is proportional to the force and the mass is constant, then the charge is also proportional to the acceleration. So, this is an example of accelerometer. These accelerometers can be used to help you identify orientations if something is moving around into different directions. Also, these accelerometers can be used to send vibrations. So if you have sensitive electronic equipment and you wanna know those vibrations, if they get very frequent, an accelerometer can be used for those purposes. To let you know some facts, accelerometers are used in tablets, computers, and digital cameras, as well as our cell phones, so that images on screens are always displayed upright. So, as you can see, to our cell phones, it manages to know what direction you're holding it. It is because of accelerometer. It works by sensing the acceleration of gravity, and then you can calculate what direction the phone is facing. You may wonder how a piece of electronics senses something mechanical like acceleration. It is because of micro electromechanical systems, or MEMS. MEMS are kind of like silicon integrated circuit, but they are mechanical in nature. There are very tiny mechanical structures that can interface to electronics. This is a tiny resistor. The lighter colored material is actually electric conductive silicon, and this darker area that's been etched away doesn't conduct. This long winding electrical path forms a resistor, very similar to how long pieces of wire would also have a significant resistance. So if you made an electrical connection between these 2 points, you'd have a microscopic resistor. Now, in order to understand how an accelerometer works, let's look at a MEMS capacitor. It doesn't look like a capacitor, does it? Well, remember that all capacitor really is two conductive plates that are electrically separated. So here are the two terminals of the capacitor. Over here, we have what's called a cone finger arrangement. The two structures are very close to each other, but they aren't quite catching. Let me highlight it for you. Now, it should be more obvious that you have parallel surfaces which form a capacitor. But this is no ordinary capacitor. It's a physical structure that can move. This thing over here is basically a tiny weight made out of silicon, and it's kind of like a suspended mass on the end of a spring. Movement, vibrations, and even gravity can cause this little mass to move around, and when it does, it shapes the entire comb finger structure. When the fingers move, the distance between the fingers changes. And when the distance between the fingers changes, you get a change in capacitance. A modern MEMS accelerometer will contain structures similar to this, except with even more fingers to increase the surface area, which increases the capacitance, which makes the change in acceleration easier to detect. So here's another electromechanical capacitor, except it senses a acceleration on the horizontal axis. When the suspended mass moves in the horizontal direction, the surface area between the fingers changes, and then you can have some electronics to sense the change in capacitance gain. That will be the end of this video tutorial.